Okay, so now for a slightly harder integration. So this one we'll talk about as we go through. So in order to complete this first question, you firstly need to find a factor of this particular cubic. And what I'd say is try when x equals 1 or 2, minus 1 and 0. So I'm going to try when x equals 1. So I'll just do this underneath. So f of 1 equals, I should probably have put f of x here, but 1 plus 3 is 4. 4 plus 1 is 5. 5 minus 1 is 4. So I'm not going to do f of 1. I've just mentally calculated that and found it doesn't work. Let's try minus 1. Minus 1 cubed is minus 1. Squared is 1. This one is minus 1. So I've got effectively minus 1 plus 3. Take away 1, take away 1. So 3 minus 3, which is 0. So that implies that x plus 1 is a factor. So now we've seen this before. What I need to do is long division. So x cubed goes up here, plus 3x x squared plus x minus 1. I'm going to do full polynomial division here with x plus 1 on the outside. X into x cubed is x squared, and then multiply through. I get x cubed and then plus x squared. Subtract at this point, disappears. This one becomes 2x squared, and bring down the next term. X into 2x squared is a 2x, and then again, if we multiply, we get 2x squared plus 2x. So then when we subtract, this one cancels. This one becomes minus x, and then bring down that minus 1. X into minus x is minus 1, and then multiply through, we get minus x minus 1. Ooh, that's a 1. And then when we subtract, we're left with nothing. So minus 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 is a minus plus. So it just cancels out, but just double check that carefully. So we know that y is actually equal to x plus 1 multiplied by x squared plus 2x minus 1. Now, I already know that this doesn't factorize, but you should check if it factorizes just in case. This doesn't factorize, it's a bit nasty, a bit misleading as well, because it looks like it might factorize. But to get this end number here, you can't get a positive 2 in the middle. So I'd advise completing the square maybe on this one, just to find the roots, or just use your calculator. I'm going to go complete the square just so we can see it. So this is x plus 1, bracket all squared, minus whatever's in here squared, and then don't forget this minus 1. So when we come to finalize that, we get x plus 1 all squared, minus 1 is minus 2. So now what I want to do is I want to find when this equals 0. So when does x plus 1 squared minus 2, when does that actually equal 0? Because that's going to tell me the root of this. So obviously I can find the root here. The root of this one's really easy. It's just minus 1. I need to know this one now. So this one's fine. I just want to find this. So 2 over to that side. So I get x plus 1 squared equals 2. Square root. So x plus 1 equals plus or minus root 2. And that's going to be really important. And then take away the 1. So here we've got minus 1 plus root 2 or minus 1 minus root 2. If you look at the second part of this question, you'll see that this is important because these two answers here are the limits of my function. But we'll come to that in a second. So when we come to the sketch, let's get rid of this bit. We know some of these values. Now, I would advise figuring these out as numbers. So minus 1 minus root 2 is minus 1.414, and minus 1 plus root 2 is equal to 0.414. Nope, sorry, minus 1 minus root 2 is actually minus 2. There we go, 0.414. So these are the two numbers. That's just going to help with the sketch. So I know when I come to sketch this, I know it's a positive cubic. I know that minus 2.414 is somewhere over here, and 0.414 is probably about here. And I know that it goes through minus 1 as well, which is probably around there. So now it comes up, it goes back through this point, and then it goes through that point. Uh-oh. Oh, didn't mean to delete both. No, you stupid thing. So this is why I don't usually put marks on until after I've drawn it, because it's just a quick sketch, so we can put that in. This point here is -1. Don't really care about that, but I'm going to label it. So this one was -√2 minus 1. This one is -1, and this one is -1 plus √2. Okay, so there's my sketch. You should put these, all the intercepts on and everything else. Sometimes you might want to find the turning points. I don't want that for this particular sketch, but in future, I should really tell you in the question whether I expect that. I don't expect it for this one. So there's my sketch. And the reason I wanted us to do that is because in this next one, we're integrating. And it's really important to figure out what in the world you're doing. So you're trying to find, and I should elaborate on this question, you're trying to find the area between y, the x-axis, and these two top and bottom lines. So in other words, if I draw a line here, that's my bottom limit, and I draw a line here, I want all the area underneath the curve, and that's enclosed by the curve and the x-axis. So hopefully you can see that this top bit of the curve is enclosed here. So it's actually this area inside here. That's what I want. The other area enclosed by the curve and the x-axis is actually underneath, is this section here. And it's really important to note when you integrate, an area above the x-axis like this is always a positive area, and an area below the x-axis like this is always a negative area. So I'm going to do this integration in 2 different steps. You don't have to, there is a way to combine this, but I want to keep it separate just so you gain some understanding at the moment. So I'm actually going to do this as 2 different integrations. I'm going to do this from my lower limit up to the point where it meets the x-axis, which is -1 in this case. So that's where I'm going to go to at this point. So that's going to be my first integral that I do. And then what I want to do to that is I want to add to it whatever areas under here. Now, unfortunately, looking ahead here, I can see that this area is going to be negative. So if I add a negative to it, it's actually going to reduce it. So I don't want to add it. I actually want to take it away. And you'll come to find that when you do this, you'll find this one is positive because it's above the x-axis, and you'll find this one is negative. So there's 2 ways of thinking about this. You can just turn this into a positive and add it, or you can stick a negative here and just take it away. I would advise doing this as 2 separate integrals until you're ready for that step though. So I'm actually going to separate this off, and then we'll add these together separately. And before we do it, I'm just going to delete all of this, just so we've got room now. There we go. So most of this step is going to be the same. The only thing that's different is when I come to put my limits in. So on the top, I just want to integrate y. I'm going to go straight into it actually, rather than writing out the question. So I'm integrating this thing here. So this is going to be x to the 4 over 4 plus just x cubed here. The 3's will cancel. Plus x squared over 2, and then minus x. So hopefully I don't need to go through that, but if so, feel free to ask. But just be careful when integrating. And then we want to put in the limits. Again, you can use your calculator here, or you can do what I like to do, which is try and do most of it in my head. Obviously, when you're using something like a surd, it's going to be quite tough to do these to the 4, to the 3, and to the 2. So I am going to use my calculator just to skip through that a bit faster. So my first bracket that I open up is going to be the -1. So it's going to be a quarter minus 1 plus a half. And then this minus and minus will also become a +1. So just double check you agree with those. I've done all the signs for us there. Minus, we want to get rid of the bottom limit. So when I put this into my equation, as I say, I'm going to cheat here. So I'm just going to use my calculator to figure that out. So I'm going to do that to the power of 4, which is, it doesn't give me a really nice answer, but we'll put in and we'll just round it in a second. So that gives me 8.49264 ... When I put it in cubed, let's just get my answer there. If I cube that up, I do get a nice answer here. I get -7 minus 5 root 2. So we'll come to that in a second. So we've got this one plus this one, or to take away this in this case, and then plus that squared, but divided by 2. So that's a 3 plus 2 root 2 all divided by 2. And then minus x, which is just this. So minus a minus and a minus is a +1, and a minus and a minus is a plus root 2. So that's what we get there. Now, this -1 and +1 will cancel out. So I've just got a quarter plus a half, which we hope know is 3/4. And then, so I've just got this mess to deal with in here. Now, what I could have done is just put all that in at once, which I am actually doing now. So I'm just coding my calculator to do all that at once. So I'm going to put -1 minus root 2, and then put that in my calculator. And then I'm going to put ans to the power of 4 divided by 4, plus ans cubed, plus fraction button, ans squared, and then over 2, and then minus ans. Pressing equals. My calculator panicked for a little bit there, but it gave me, I feel like I've made an error somewhere. Hopefully we're okay. We've got a -1/4 here. So that came from this section here. There we go. Okay, so when we come to my final answer, we get 3/4 minus a quarter. So 3/4 plus a quarter is 1. So quite a nice answer here, actually. Almost seems a pain after going through all of that just to find the area is 1. Remember, that's 1 square unit. I'll just put that there. The second bit, same idea. Everything here is actually the same. I'm going to cheat a little bit. I'm just going to copy this. Copy, and I'm just bringing it down to here. So all of this is the same apart from the limits. So this top limit up here is actually going to become the bottom, and the bottom limit needs changing, but it will be similar to what's up on that top. So I'm just readjusting that. So this is a minus and a plus here. Right, there we go. So same again, I'm going to put these two numbers in. I'm going to do it a little bit faster this time. So I've already put -1 in. I know -1 gave me 3/4. So I'm not going to be silly and do that again. I know it's 3/4, so I'm just going to whack 3/4 right there. So remember, we did that up here when we got 3/4. So all I need to do is -1 plus root 2. Again, I'm going to stick that in my calculator. So luckily, I've already coded most of this in my calculator. So I'm going to just update my calculator with -1 plus root 2. Then I'm going to go back up and find my equation with the answer to the 4/4 plus blah, blah, blah. And I'm just going to press equals. And that tells me -1/4. So after all that, not much to put in that big bracket. -1/4 minus 3/4 is -1. Interesting. So had you not looked at your sketch, if you were to simply just put these together and you were to integrate the whole thing, 1 plus -1 would cancel out, and that gives us 0. The reason for that is the area of the hump above and below this axis for this particular equation. This is not always true, but I've just done this one to emphasize that. They're the same size. So if you do the full integral, the top hump, because it's positive, the bottom hump, because it's negative, they actually cancel each other out. So the area it's telling you is 0. That's not true. But you can't, it's not, you can clearly see from the sketch, you've got area here, you've got space. So you know it's not 0. And the reason for that is because of that negative. So what you want to do when you come to your actual area, so the total area is equal to 1 from this first one, and then ignore the minus, it's actually a positive, area is always positive, so you want to add those two together. So we get 2 square units, and that's the final answer there. So long and short of it, if you've got an area above and an area below, usually they'll be different, so they won't cancel out, but you really want to make sure that you're either doing them separately, so you're doing this top one up here, and then you're going to take away the integral of the bottom down here. So you actually need to split them up. So you want to find out effectively if you've got A and B, you need to create this midpoint. Let's call it C. So when you're doing the integral from a to b of y, and you find it crosses the x-axis, and you've got a bit on top, you want to split it from a to c of y, and you want to take away, it's always a takeaway here, because it cancels out with the minus that you get from here. And that is from c through to b dx. So that's the takeaway kind of bit from this. But I like to think of it more logically and think about the areas themselves. But that is a formula, it's a bit of a takeaway formula, which you should find for these particular ones. Again, hopefully this helps. If you need more, just let me know.